Hey there, my name's Kevin Reynolds, and this is Screencast assignment number 2, where we're going to focus on peptide formation. Specifically, we're going to look at the formation of DARIC, which is a combination of 4 amino acids, those being aspartate, glutamate, arginine, and lysine, as seen here with their one-letter codes. One big thing we're going to look at is the actual structure of each of those amino acids. So starting off, we're going to slide over to here where we're going to see the makeup of each of those. So one big thing to note is that our aspartate and glutamate are both going to be negatively charged, while arginine and lysine are going to be positively charged. It's going to affect our overall net charge. So firstly, we're going to start with the peptide formation. This is done through a process called dehydration, where we're going to lose, in a sense, the alcohol off of a carboxylic acid and one of the hydrogens off of our protonated amine, which is going to form these bonds, which we'll see in larger scale when we actually form the entirety of the molecule of DARIC. Note that each of them are labeled out in DEREK, they're single letter formations. One big thing to note is the little blue dots across the actual backbone of the structure. These are indicative of our anomeric or alpha carbons, which are going to be the roots of each of our amino acids. One big thing we're going to look at first is going to be our actual D, or our aspartate molecule. So when we look a little bit closer at it, the little squiggly is going to be indicating everything past the actual molecule. So aspartate is going to be the H3N positive to the carbon with its backbone or residue going up down to the carbonyl. This kind of formation allows for some resonance across the backbone by an intramolecular shift of our hydrogen to the oxygen and the double bond kicking down, forming this little structure, which is actually going to grant and warrant restricted rotation across the molecule. One more thing to look at, sliding back up, is going to be this centralized R, or arginine group, with the 2 glutamate side categories. We're going to slide down over to here where we're going to start seeing that in this kind of planar formation. This formation is actually going to be able to allow us to see 2 six-pointed planes formed from glutamate to arginine and arginine to glutamate, which actually allow us to see 2 different things. We can rotate about our nitrogen groups, looking at the carbonyl shifts, which is going to give us our phi angles. In this case, it's going to be our negative degreed phi angle. And similarly, or vice versa, is looking at our psi angles, which is going to be from the actual alpha carbon to our nitrogen groups.